Welcome back to Blueprint to Reality. Today, we're diving into a critical topic for modern infrastructure: how engineers make bridges earthquake-resistant. Bridges are vital lifelines, connecting communities and supporting transportation networks. But when earthquakes strike, the forces can be immense, threatening their stability. So how do engineers design bridges to withstand seismic activity? Let's explore the key techniques that keep these structures standing tall during earthquakes. Understanding seismic forces. First, let's quickly understand what happens during an earthquake. Earthquakes generate lateral forces, side-to-side movements, that can shake a structure violently. Bridges are particularly vulnerable because they span long distances and need to support heavy loads, like vehicles and trains. During an earthquake, the ground beneath a bridge can move unpredictably, creating forces that can cause columns to crack, joints to fail, or even lead to complete collapse if not designed properly. Flexibility through base isolation. One of the most effective techniques engineers use to protect bridges is base isolation. This involves placing flexible bearings or isolators between the bridge structure and its foundation. These isolators act like shock absorbers, allowing the bridge to move independently of the ground during an earthquake. By isolating the movement, the bridge can sway with the seismic waves without absorbing the full force of the ground shaking, greatly reducing the risk of damage. Dampers to reduce vibrations. Another key tool in earthquake-resistant design is the use of dampers. Think of dampers as a way to slow down the vibrations caused by seismic forces. Engineers often install tuned mass dampers or viscous dampers within bridge structures to absorb and dissipate energy. These devices can reduce the amplitude of vibrations, minimizing the impact on the bridge's key components like its deck and supports. Dampers essentially help calm the shaking, protecting the bridge from excessive stress. Reinforced pillars and foundations. The next critical aspect of earthquake-resistant design is reinforced pillars and foundations. Engineers use reinforced concrete and steel to strengthen the columns and piers that support bridges. This reinforcement helps resist the intense shear and bending forces caused by earthquakes. In some cases, engineers also use deep foundations or piles that extend far below the surface to reach stable soil or bedrock, ensuring the bridge remains stable even when the ground above it shakes. Expansion joints. Lastly, bridges are equipped with expansion joints. These are gaps or flexible connections that allow different parts of the bridge to move independently during seismic activity. By providing space for controlled movement, expansion joints prevent parts of the bridge from colliding with each other or cracking under stress. They help ensure the bridge can flex without breaking. By using base isolators, dampers, reinforced pillars, deep foundations, and expansion joints, engineers create bridges that can resist the devastating effects of earthquakes. The goal isn't to make bridges completely unmovable. It's to allow them to flex and absorb seismic forces without collapsing. Thanks for watching Blueprint to Reality. If you enjoyed this breakdown of earthquake-resistant bridges, be sure to like, subscribe, and hit the notification bell for more insights into the world of civil engineering and design. Stay safe, and see you in the next video.